Hello and welcome to section 1 of unit 6. This section will introduce you to the various applications of radioactivity in various spheres of human life. By the end of this session, you should be able to explain the applications of radioactivity in archaeological or environmental studies. You should be able to explain the applications of radioactivity in industry and agricultural practice. The modern world has come to witness application of radiation activities of subatomic particles and electromagnetic rays in various spheres of human's life. This has contributed immensely to the improvement of the quality of life. Radionuclei have found application in archaeological research, agriculture practice, diagnosis, treatment of various diseases, and even in nuclear reactors. In this slides and the slides to follow, we shall be looking at the applications of radioactivity. One of them is the use of radionuclides in archaeological or environmental studies. Now, environmentalists or archaeologists or even geologists apply radiological dating to determine the age of artifacts, be it a plant or an animal. They can find the age of woods, fibers, natural pigments, bones, and even cotton. They usually do this by measuring the carbon-14 in these artifacts. The carbon-14 is a natural occurring radioactive form of carbon. The radioactive carbon, that is the carbon-14, is produced continuously in the upper atmosphere as nitrogen atom captures cosmic ray neutrons. Now, if you have nitrogen and it interacts with neutron, it can produce this carbon-14 with the emission of air. Let us look at how these researchers use carbon-14 dating to predict the life or the age of these artifacts. So, carbon dioxide 14. So, carbon dioxide, where the carbon is from the carbon-14, is produced from the reaction of carbon-14 with oxygen. Now, as humans continue in life and consume food and have life, they consume this carbon-14 into them. After the death of the human or the plant, the uptake of carbon dioxide stops. The carbon-14 will undergo beta decay, and the amount of radioactive carbon in the plant material or the human will decrease steadily. So, all the carbon-14 will be converted to nitrogen with the emission of beta particle. Researchers will then use the half-life of carbon-14, which is 5,730 years, to calculate the length of time an event or the death of that plant of human being took place. Older objects can be studied using potassium to argon or other radioactive nuclides that are having a longer half-life. For example, the potassium-40 and argon-40 has a half-life of 1.3 billion years. Let us consider a typical example here, or an application of this radioactivity. The question says that a sample from a shroud gave a count rate of 14.1 decays per gram minute. The half-life was found to be 5,730 years. And they said, how old is the shroud if a fresh sample is 15.3 decades per gram minute, and if it were 2,000 years old, what count rate would it give? Now, to address this problem, we need to calculate an age. We need the value of n naught over n. This is the ratio of the count rate of fresh carbon sample divided by the count rate of old sample. So we quote the formula ln n naught over nt equals lambda t, or ln nt over n naught equals negative lambda t, where the two equations are equal and t is the age calculated for. So we quote the formula ln n naught over nt equals lambda t, where our n naught is the initial activity and it is 15.3 d per g minute, and our n is the final activity, which is 14.1 decay per gram per minute or minute. We have those parameters. We are to look for the time, and to look for the time, then we need the decay constant. But we know that half-life is given by 0.693 over the decay constant. So we can solve for decay constant, where decay constant will be 0.693 over the half-life. The half-life was given to be 5,730 years. Now when we solve, we substitute these values and we solve, we are going to get a half-life of a decay constant of 1.209 times 10 to the power negative 4 per year. Now we can substitute this decay constant into our main equation, ln n naught over nt equals lambda t, and we solve for t. Now when we solve for t, we get time to be 675 years. So that will be the time. Now to answer the question B is asking us to find the count rate if the shroud was 2,000 years old, which means that we need to find the final activity. Let's assume that the shroud lived for 2,000 years. We already have all the parameters that we needed. We have the initial decay, we have the decay constant, which is the lambda, alright, and now we have been given 2,000 years, which is our time. So we will solve for nt, that is the final activity. When we substitute the values and we simplify, we are going to get nt to be 12 decay per gram per minute. Now let us shift our attention to the applications of radioactivity in the industry. So radioactivity can be applied in the industry to disinfect food, medical equipment, and other substances by exposing them to these radioactive radiations such as X-rays, and this will lead to killing of any germs that are in this kind of equipment or food without leaving any traces of radioactivity that will harm the individual. Radioactivity can also be used to remove toxic pollutants such as exhaust gases from coal-fired power stations and the industries. Again, many of the fabrics used to make clothes are irradiated before being exposed to a soil releasing or wrinkle resistant chemical. And this treatment makes the chemicals bind to the fabric to keep our clothing fresh and wrinkle free all day, yet our clothing does not become radioactive. We can also say that one of the applications is that non-stick cookware is treated with gamma rays to keep food from sticking to the metal surface. And finally, we can find an application in agriculture where in the agriculture industry they make use of radiations to improve food production and packaging. Plant seeds, for example, have been exposed to radiations to bring about new and better types of plants. Insect population are also decreased by the use of dangerous pesticides. This is a self-assessment question and you have to try your hands on it.